All right, our last example. We've got Nate. Nate starts a lawn mowing business. In his business, he has expenses and revenue. If we haven't seen this word revenue yet, that is expenses is money he has to pay out. So his expenses, money he has to pay. Revenue is money he brings in. So it would be like profit. How is he making money? So he has to pay money for certain things, and then revenue is the money he's bringing in that he's making. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per lawn. So he has to pay for his lawnmower $200. He has to pay for gasoline, costs about $2 a lawn. And then the money that he brings in, this is essentially what he's charging people. He brings in $25 per lawn. At what point will Nate's revenue exceed his expenses? So before he mows any lawns, he's already put $200 in, right? He's paid for his lawnmower. He doesn't automatically bring in $200 until he starts mowing lawns. So in the beginning of his little business, he has paid more than he has made. So the question is, at one point will the revenue exceed or be more than his expenses? So we're going to write a system of equations. We're going to define our variables first. Let's let x equal, at what point will Nate's revenue exceed his expenses? I always look at the question they're asking to guide my variables. He is paying gasoline per lawn and he's making $25 per lawn. So I'm going to let x equal the number of lawns. I'm going to let y equal total dollar amount. It could be total expense or total revenue. So just a total dollar amount. So let's write an equation for Nate's expenses. What is he spending money on? So his total dollar amount for expenses is equal to, he's got to pay for a lawnmower, $200. He also has to pay for the gasoline, which is $2 for every lawn. So we're going to say $2 times every lawn that he mows. So those are his expenses. Let's write an equation for his revenue, the money he's bringing in. So the total dollar amount for his revenue will be equal to, let's see, it said that his revenue is $25 per lawn. So he's making $25 times every lawn, which is X. Now to solve for X and Y, here's just something else that we haven't mentioned yet. If you have an equation in one variable, if I had just the X or just the Y, I could solve for X and get an answer. Or if I had just a Y, I could solve for Y and get an answer. When you have two variables and you need to solve for X and Y, you're going to need two equations with an X and a Y. So that's why we have a system, because we have two variables we're trying to solve for. I just want to make sure that we are understanding that. Okay, so let's solve our system. We're going to do substitution because that's the lesson we're in. It's also a nice method to use because we have a y equals here. So we have a variable isolated. We have a y equals there. So we're just going to pick one of them. Maybe this y equals 25x. I'm going to substitute that into the other equation for the y. Rewrite this equation, 25x equals 200 plus 2x, and now we can solve. I'm going to subtract 2x from both sides. So we have 23x equals 200. Divide both sides by 23. And then what you're going to find is it doesn't divide evenly. X is equal to about, I'm going to do some rounding at 8.7. So at about 8.7 lawns, the money he's spending and the money he's bringing in are even. This is when he breaks even, essentially. He has spent money, but he's brought in enough to where he has broken even, like I just said. But he can't mow 8.7 lawns. And the question is, at what point will Nate's revenue exceed his expenses? So it's going to take 8.7 lawns, which we know he can't mow exactly that amount, for the revenue to catch up to what he spent or what he's spending. So he actually has to mow more than that. So we are going to round up. Nate needs to mow 9 lawns in order for the revenue to exceed his expenses. All right, so there it is, just written out in a sentence. That is answering the question. So I see that there is one more example to do in this video. I'm not going to do that right now. Don't cross it off just in case I want to come back and fill this in later. But it's essentially very similar to what we were doing. Maybe in class, we'll just make sure we can set up the equations. I think that ends up being the hardest part. But the solving is similar to all these examples. So we'll just call it good here and end our night of notes.